All right, absolute value inequalities. It says solve each absolute value inequality. Other than no solution, use interval notation to express solution sets and graph each solution set on a number line. All right, what do we know about absolute value? It's the distance that a number is from 0, correct? So when I take an absolute value of something, it always comes out to be what kind of a number? Positive number, because distance is always positive. But we know that what's inside those absolute value symbols can be a positive or a negative number. Does that make sense? So like if I had, I'm just going to write it over here on the side here. If I have the absolute value of x is equal to 4, this number here could be 4, or it could be negative 4, right? All right, so it's the same idea with the absolute value inequalities. I work it out the same way. Let's read what it says here in the box. The box is kind of like you have to memorize a little bit of something, and I'll show you another way possibly too. You could use either one, of course. So it says solving an absolute value inequality. If u is an algebraic expression and c is a positive number, then the solutions of the absolute value of u is less than c are numbers that satisfy negative c is less than u less than c. So what it's saying there is it's an and statement, okay? And so I can remember that because when I look at this right here, I see this as, what kind of a symbol is that? Less than, okay? So I use it as a play on the words. It's a less than symbol. So therefore I know it's and, which means when I go to give my solution or I go to graph it, this is only going to be where they overlap. Okay, it's what makes both parts of it true. It's an and statement because it was a less than symbol. Number 2 says the solutions of the absolute value of u is greater than c are the numbers that satisfy u is less than negative c or u is greater than positive c. The way I can remember this, again, is a play on the word there. So this is a greater. And so I know it's an or statement. So when I give my solution or when I graph it, I know I'm going to give everything that's going to make both of them true. Everything that's going to make either one of them true is the way I should say it, okay? And so if you can remember that it's an and statement, you can just take the absolute value and set it with inequalities with negative c on the left and positive c on the right. You're welcome to. But I do these just like I solve the regular absolute value equations. So we're going to take, we know what's inside can be a negative x, and I set it less than or equal to 6. And what's inside could be a positive, and I set it less than or equal to 6. Now, is this an and or an or statement? It's a less than symbol, right? So it's an and. And so work both of those out. So negative x is less than or equal to 6. Divide by negative 1. X is greater than or equal to negative 6. Okay, then we have a positive x is less than or equal to 6. And we said this was an and statement. So there's my two solutions. So there's, what's that? No, we can. Our x, what's inside the absolute value symbol, can be negative, okay? It's what's on the outside there. So where we have in the original problem where it says less than or equal to 6, that number there has to be a positive number. So when you take it out, it has to be positive. Alright, so since it's an and, I'm going to do the little graphs above and below it. So x is greater than or equal to negative 6. Less than or equal to positive 6. And we see they overlap where? Between the negative and the positive 6. The negative 6 had a bracket from above. The positive 6 had a bracket from below there. And so there's our graph, and from there we can pull our solution. So our interval notation is -6 to 6. And our set builder notation is x such that. Now we want to put that as one inequality, okay? So we're going to have to actually look at it a little bit instead of just pulling what our answer was. That's why at the beginning I didn't point out that our answer was what went in it. So we have, what is that? -6. We know x is in the middle and +6. We always use less than symbols, and is it going to have an equal to? Yes, on both of them. And then close your set builder notation. Alright, so how about 17? Well, we know the x that's inside, so we can take the negative of what's inside. It's greater than 6. Or the positive of what's inside is greater than 6. Now, since this is a greater than symbol, right? This is going to be our or statement. Because it's a greater. So let's solve both of these. Divide by the negative, flip the inequality. This is an or statement. I know that everything that's graphed for each of them is part of my solution, so I'm just going to do it on the number line. So x is less than -6 with a parenthesis. And x is greater than +6 with a parenthesis. And so how would I write this in interval notation? Negative infinity to what? -6. The union.
And then 6.
Very good. Alright, then 18. We know the negative of what's inside is less than 7. And we know the positive of what's inside there is less than 7. And is this an and or an or for 18? Yeah, it's less than, so it's an and statement. Now what I'm going to do, instead of distributing the negative, I'm just going to go ahead and divide by it. You can distribute it, but when you get to some fractions, sometimes it confuses you. So I'm going to go ahead and just divide by that -1 to begin with. And then solve. And no, positive's not going to change it, so it's just x minus 3 is less than 7. And solve it. We'll graph them individually, so greater than -4, less than +10. And since it's an and statement, we're looking for the overlap, which again is in between them. We both got parentheses. And then I want to practice going ahead and putting that as one inequality. So x such that -4x 10. You use less than symbols, and do either one of them have an equal to? No.